Okay, so I can do a sketch of A and B. Now A's got the position vector, so I can write it as RA equals 4I minus 5J, and I can also write it as a column vector like that. And all it means is that the vector that goes from the origin goes to the point 4 minus 5. So for A, point A is going to be 4 minus 5, say something like there, A. 4 minus 5. And the point B has a position vector minus 5I minus 2J, and I can write it as minus 5 minus 2 as a column vector like that, and it just means the point B is going to be the point minus 5 minus 2, which is something, it's probably about there, isn't it? B, it's only a sketch, minus 5 minus 2. And for part A, we've got to try and find the vector AB, the vector that goes from A to B. So what we're looking for is this vector here that goes from A to B. And remember, what we're given is, we're given this vector here, which is the position vector of A, which is that vector there, and we're also given the position vector of B, so we're given that vector there. And we know that that vector there is, I mean, I'm not saying anything new, I'm just writing it on the diagram. That vector there is 4 minus 5, and that vector there is minus 5 minus 2. Because they start at the origin, these position vectors, remember you can find a vector by doing the position vector of the end point minus the position vector of the start point. Well, the start point is just 0, 0. So, yeah. Now we want the vector AB. Now that's the same as position vector of B minus the position vector of A. So it's just going to be minus 5 minus 2 minus 4 minus 5. Minus 5 minus 4 is minus 9. Minus 2 minus minus 5 is minus 2 plus 5, or is 3. So we've actually done it now. Sorry, that's a bit confusing. We've done it. If we want to write it in the way that they've written the question, we can write it as minus 9I plus 3J. Okay, and then part B, it's asking us to find the magnitude of the vector AB. So we've got the vector AB. It's the blue line that goes from A to B. We now want the length of that line, and we find the length of the line by using Pythagoras. So it's going to be the square root of, and then we look at the change in the x coordinates, square it and add it to the change in the y coordinates squared. So but we know what the change is because we've already worked that out. It's minus 9I plus 3J. So really all we have to do is minus 9 squared plus 3 squared, and that will come to 81 plus 9 is 90. So we want root 90, and we can simplify that. Root 90 is the same as root of 9 times 10, so it's the same as 3 root 10.